down here and get started? Shh. So on the agenda today is we'll do the homework quiz and then talk about section 14.1. What do you guys want to do first? Or 14.3, excuse me, the last section we need to talk about.
Slant.
I don't know what you're asking me to.
Sorry.
That's okay.
What's it called? You guys do you want to take the homework quiz first or notes?
We can do the quiz first. That's fine. Sounds like that's the majority feeling. Did you want to ask some stuff before we started? You do a few minutes here.
Yeah.
Okay, what do you got?
Can you do a vertical asymptote blank out of fraction?
Sure. Okay, so let's say we have this rational function, and we're looking for stuff about it, like the vertical asymptote and stuff. What would I want to start by doing? What's that? Factor. Good. How does the numerator factor? 2 and 1. So x plus 2, x plus 1. Do we remember how to do that? If you don't, speak up. How about the denominator? Oh, that was impossible. Sorry, do that. 4 and 1. Great. So far, so good?
Yeah.
What do we notice? The x plus 1s can reduce. Okay. So if I want the vertical asymptote, what do I use? The denominator. Which denominator? I see 3 of them. The reduced one. Excellent. We just set that equal to 0. Okay. If I want the removal discontinuity, how do I get that? The one that was removed, we set equal to 0. Oops. Equal to 0. And then if I want the point, the location of that hole, I have the x-coordinate. How do I get the y-coordinate for the location of that hole? I plug it in there. So when I plug -1 for the top, I get 1. When I plug it into the bottom, I get 3. So there's the location for my removal discontinuity. What if I wanted the zeros? How do I get those? Without using the calculator, you could do that, I guess. But, like, come on. What do I use to get the zeros? When is a fraction equal to 0? Not the denominator, the numerator. So I'm going to set the reduced numerator equal to 0. So far, so good? Okay. And then the last thing we might ask about is like horizontal asymptote, slant asymptote. What are the rules for this? What do we have to look at? The degrees, great. So the degree of the numerator is the same as the degree of the denominator, very good. So that was case 2. What is how do I find the asymptote when the degrees are equal? Excellent, yes. In this case, it's just 1 over 1. When the degrees are equal, you have a horizontal asymptote, and the location of that is just going to be the leading coefficient of the numerator, which is just 1, over the leading coefficient of the denominator, which is just 1. That gives you 1 over 1 is just 1, so it's y equals 1. Pat?
For the 1/3, wouldn't that be 1/2? Or is that, how would you get 1/3?
So I plugged -1 in here.
Oh.
So -1 plus 2 is 1 over -1 plus 4, which is 3. Is that? So you plug it into the reduced to get the y coordinate. No, the slant asymptote is when the degree of the numerator is greater than the degree of the denominator. There you have to do the polynomial division.
Oh, okay. Let's hope it's not that one. Wait, what number do you use for, how do you find the number?
It's from the denominator. Be -4 in this case.
So if it was like, for down, if it was like the top was x to the third and the bottom was x to the second.
You have to do long division in that case, not synthetic. Natalia. So the other kind of question I told you guys would be on the quiz is I would give you a bunch of information like this and ask you to draw the picture afterwards.
So you just plot that stuff?
So you'd basically draw in that stuff, yeah. I would give you more information than just this. I'd give you the end behaviors also, because you would need those to be able to draw the picture for sure. But yeah, that's the gist of the quiz. It's just 14.1 stuff. It's all having to do with graphing, which is not too bad, right? And just keeping straight what to do, right? The actually doing it is easy. Knowing which one to do or what to do with what, that's the harder part, right? But none of this was like much symbol pushing. You know what I mean? Did that help, Katerina?
Yeah.
For sure? Okay. What do you guys think? Do you have more stuff to ask me about 14.1? I'm happy to do more if you still have more questions. I have a few more minutes. Sure. So there I noticed the degree of the numerator is 2. And the degree of the denominator is 1. So this is a slant asymptote problem. To get that, I'm just going to do polynomial division. If I look at the denominator, I notice that is monic, degree 1 with leading coefficient 1, so I can do synthetic division with this. So I will choose to do that because it's considerably more expedient than having to do long division. So I'll set up my synthetic division. So the part that I care about, remember this is remainder, constant, and x. That's the part I care about, because that is what will give me my slant asymptote. So it can be really quick getting that. Just depends on like how nasty the polynomial division is, right, Elise?
Yeah.
If it's an easy synthetic division like this, it's like piece of cake. Not too bad. We've practiced doing that a bunch of times in the previous chapter. If it's long division, where you have like, it can be a kind of a bear sometimes. I wouldn't expect to see that here, considering we didn't spend a ton of time doing long divisions last chapter even. Does that jog your memory? Okay. We'll pause this recording and we'll take the quiz and then we'll come back and do 14.3 stuff. Sound good? So let's dive in here to 14.3a. So here we're talking about inequalities. So I'm going to start with a couple of review problems, and we'll start way back in ancient history with like something like this. So think back to your old Algebra 1 or pre-algebra days. How do we solve something like this? Okay, so the first thing I do is subtract 10 from both sides. That's good. Okay, then what? Divide by -4. Yeah, what do I have to be careful about here? Good. The inequality changes direction. And then sometimes we write our answer on the number line, right? So at like -2, would I draw that with an open circle or filled? Open. Why open? Yeah, because it's a strict greater than symbol. And which way should I be going? Left or right? To the right, where those are the things that are bigger than -4 live. Now, how would I write this using an interval notation? Positive infinity. And then what do I need here? Parentheses or brackets? Well, you know a parenthesis goes on all the infinities, right? How about for the -2? Should I get a bracket or a parenthesis? Is -2 part of the answer or not part of the answer? It's not part of the answer, right? Because it's not equal to, we didn't draw it with the filled circle. So which one is not part? Parenthesis or bracket? Parenthesis. The brackets are including. Everybody's okay with that? So that's like an Algebra 1 kind of example. How about one like this? This is an Algebra 2 kind of example. You should have done this last year. I think you did through quadratics at least. How do I do something like this? Nope, don't want to do that. I have to do something before I start doing any algebra steps. Nope, I don't want to do that. I want to pretend this is the equation where it's equal to 0. And then you could add 4 to both sides and square root, or you could factor the left-hand side. Either would be appropriate here to solve. So let's just pretend we factored, because Well, we've just been doing that. So what I do now with those two solutions is I know that the only places where a polynomial, which is continuous, can change from negative to positive is where it hits 0, where it's crossing the x-axis, right? Everybody's okay with that idea? So I'm going to be concerned about, or I'm going to draw what's called a sign diagram. I guess I'll write that. So I'm going to put those solutions on my sign diagram. Now, should those solutions have an open circle or a closed circle attached to them? Open, why? Because it's a strict greater than inequality. And then what I'm going to do is I'm going to be concerned about each of these three intervals, right? So I'm going to pick a test value from each of those three intervals. It doesn't really matter what it is. So maybe I'll pick -3, that's less than -2. I'll pick 0, that's between -2 and +2. And I'll pick +3, that's bigger than 2. What I'm going to do with those then is I'm going to take, say, -3, and I'm going to plug it in for the x's and see what I get. And I don't really care what the number is, I just care whether it's positive or negative. So -3 minus -2 is a negative number, and -3 plus 2 is a negative number, and I know negative times negative is positive. So I'm just going to simplify this so I can just do it as a mental math problem and not worry about what the actual answer is. I just care if it's negative or positive. If I plug 0 in, 0 minus 2 is negative, 0 plus 2 is positive, negative times positive is negative. And if I plug 3 in, 3 minus 2 is positive, and 3 plus 2 is positive. Positive times positive is positive. So if I'm worried about where we're greater than 0, I care about those two places, right? So let's go ahead and write my interval notation to describe those two locations. So I have -∞ up to -2, and then +2 up to +∞. Notice I used parentheses the whole way through because I used open circles at -2 and +2. And infinities always get a parenthesis. That feel okay there? Let's do another. And it's quite worthwhile doing this is because, well, what you've seen is that more often than not with these solving rational equations, most of these end up turning into like solving a polynomial equation. And as you might have guessed, solving a rational inequality will turn into something similar to solving a polynomial inequality. So we'll do another polynomial example. Again, this is probably something you did last year in your Algebra 2 course. But if not, we're doing it now. So start off the same way. Pretend that this is an equation that's equal to 0. How are we going to solve this equation equal to 0? What's the first thing I should do? Factor out an x. Great. Agreed? You just toss it. Thanks, man. So we did that. What next? Factored out that x. Look at that piece that's remaining. What do you notice about x squared minus 4x plus 4? Should know how to factor that now, right? What does that factor to? Ruthie, you shook your head. I'm going to ask for you to tell me. And yeah, good. That's good. So then I can solve that, right? So I get 0, 2, and 2. So we'll draw our sign diagram. How many numbers are going to go on our sign diagram? Look carefully. Look carefully. Just 2, right? Why is there only 2 numbers on there? Because one number is just the same thing twice, right? So I don't actually need 3 numbers on there. Just 2 is fine. Should I use a closed circle or a filled circle for these? Closed. I said closed and filled. That's the same thing, Mr. Kulik. It's the end of the day, guys. Yeah. Why did I do that? Yeah, or equal to. That's why we get filled circles this time. Okay. Do the same thing. Let's pick some test values. 1 in each interval. So if I plug -1 in, I get negative times negative times negative. 3 negatives is negative. If I plug +1 in, I get positive, negative, negative. 2 negatives is positive. And if I plug 3 in, I get positive times positive times positive. That's positive. So, again, I'm trying to solve less than or equal to 0. So which parts am I interested in? From my sign diagram, which parts am I interested in? The negative parts? Close. You're missing something. What else did I miss? I also need the 2. Why do I need the 2? My inequality is less than or equal to 0. We know that 2 is a solution to this thing equal to 0. So that also has to be part of my solution set. So how do I write that as a interval? Well, I do negative infinity to 0 with a bracket. Why did I get a bracket here? Right. I used a filled in circle because it was less than or equal to. Go ahead, sir. I figured it was your time. Some of us are on a schedule. And how do I just do the 1 number 2, though? That's not an interval. That's just a single number, right? How do I do that? We just use the squiggly bracket and just write the number 2. What do you guys think? So far, so good? All right. Let's look at one of these where I have a rational function now. Everybody okay? So this looks like something we've been dealing with this chapter, right? So just like before, pretend that it equals 0. And when is a fraction equal to 0? Hey, there you go. Somebody was paying attention. Yeah, when the numerator is equal to 0. I really appreciate that you're like, I know the right answer. Okay. So, should I be using a parenthesis or a bracket for the 4? Bracket, why? Great. Now, these rational functions are distinctly different from polynomial functions in one very specific way. They can also include discontinuities, right? Vertical asymptotes or removable discontinuities. So we saw that a continuous function can only change sign at zeros. A discontinuous function can change sign at the zeros and a discontinuity. So in addition to zeros, we also need to worry about our vertical asymptotes or removable discontinuities. How do I get those? Oh, really? How do I find those? Great, set the denominator equal to 0. We just did this, guys. That's how you do it, yes. And these are always going to get a parenthesis. Why? Because? A reason? So, is there a point on our graph at a discontinuity? At a vertical asymptote or a hole, is there going to be a point on our graph with that x-coordinate? No, right? That's what a discontinuity is, a value for x that the function doesn't work with. That's why you're always going to be using a parenthesis with your vertical asymptote or removable discontinuity. The 0 is going to depend on the inequality symbol. That's maybe the trickiest part about this, is making sure that you use your discontinuities and that you remember to use the right symbols there. So let's see, pick some test values. Those ones look good. So let's just plug in and check. -2 minus 4 is negative. -2 plus 1 is negative. Negative divided by negative should be positive. 0 minus 4 is negative. 0 plus 1 is positive. Negative over positive is negative. 5 minus 4 is positive. 5 plus 1 is positive. Positive over positive is positive. If I care about this thing being greater than or equal to 0, which parts do I care about? The positive parts. So I care about here and here. Notice that the -1 is getting a parenthesis because I used the open circle because that was the discontinuity. But the 4 gets a bracket because that was a 0 and we had a or equal to inequality. What do you guys think so far? It's not so bad, right? Got one more example for you, and then we'll call her Dunzos for today's O. So we have the square root of x plus 4 all over the absolute value of x minus 1. Oh no! So complicated. It's going to be fine, guys. Don't panic. All right. Let's find the zeros first. Will I be using a parenthesis or a bracket for the zeros? Parenthesis, because it's a strict greater than inequality. So what am I setting equal to 0 to get the zeros? Sophia, what do I set equal to 0 to get the zeros?
Oh, zero. No. The numerator.
Yeah, there you go. I knew you knew it. Did he even try to trick you and you still outsmarted him?
Yeah,
Good on you.
good try.
All right. How do I solve that? Well, how do I cancel out the square root? Square both sides, right? And what's 0 squared? 0. And I'll just subtract the negative 4 over. I don't know why I changed colors. It is what it is. Next, we'll find the vertical asymptotes or remove discontinuities. Those always get a parenthesis. We just do that by taking the denominator and setting that equal to 0. How do I get rid of the absolute value? I just put a plus or minus on the right-hand side. But what's plus or minus 0?
Zero.
That's just 0, right? So I have x equals 1. So I'll use that stuff then to build my sign diagram. Both of these get open circles. And now we'll just plug our test values in to see what happens. So plugging in -5, I have the square root of -5 plus 4. Well, -5 plus 4 is -1. What's the square root of -1? I, which is a non-real number, right? That piece is just undefined. So that doesn't count for negative or positive. It's just nothing. Everybody okay with that? If I plug in 0, square root of x plus 4 is positive. The absolute value of anything is always positive. Positive over positive is just positive. If I plug in 2, square root of x plus 2 is positive. The absolute value of anything is positive. Positive over positive is positive. So my solutions then are those parts of my graph. So it's a little bit tricky there because I need to still do 2 separate intervals because positive 1 is not included. So everything up to positive 1 and everything after positive 1. But that's the gist of it. What do you guys think? It's not too bad, right? This is pretty doable. I like it because it's visual. I'm a visual guy. It helps me when I have like something to look at. I like drawing the sign diagrams. I think that makes life easier for me. So at this point, you guys should be able to do now the rest of the problem set, that's 35 to 57. This was the last section of chapter 14. The plan for this, the rest of the classes to break, we'll do the work/review day next class period. And then our full-length class, next week we have an X day and then an A day and a B day, I think. So the full-length class day, which I believe is Tuesday, would be the test. We'll just do some more review stuff on the X day or whatever. We'll just fill that time with whatever you guys are feeling. How's that sound? Okay. Sure, I love it. Positive attitude.